Hi, hello, welcome to Knowledge Center. In this video, let us continue the preparation for KPTCL examination. As you all know that I have done the previous videos on KPTCL preparation, wherein we have solved some examination question papers. So now I am going to continue with that. So on this board, you can observe the question here. This has been asked again in the KPTCL JE question paper. So let's look into the question here. Two generators A and B have 6 poles each. So there are two generators and both are having the same number of poles, 6. Generator A has wave wound armature. Okay, so generator A is having a wave winding, and while generator B has lap wound armature. Generator B has lap armature. So let us write it here. A is having a wave winding and B is having lap winding. That is the point. Okay. The ratio of the induced EMF in generator A and B will be dash. So they are given 4 options here. You just need to find the ratio of EMF induced in each A and B generator. That is what the concept here. So first of all, in order to solve this question, you need to know the EMF equation of generator. So generally, I will write here the EMF induced in a generator can be given as phi ZNP by 60 into A. This is the EMF equation wherein EMF induced in a generator can be obtained. Now the question is, you need to find the ratio of EMF induced in A and B generators. So if I name this as EMF induced in A, generator A, then phi ZNP by 60 into A, there is a small change we need to identify. That is, see, if it is a wave and lap winding, we have one condition with respect to the windings. If it is a wave winding, the parallel paths in wave windings will be always 2. That parallel path will be denoted as A. So in wave winding, the parallel paths will be 2. Whereas in lap winding, the parallel paths will be equal to number of poles. So this is the major condition you need to know to solve this kind of question. In a wave winding, whatever may be the number of poles, the parallel paths will be equal to 2. Whereas if it is a lap winding, the parallel paths are equal to number of poles. So that is the major point you need to concentrate so that you can get the answer. So now if I write EMF with respect to generator A, I can rewrite the expression like this. Phi ZNP by 60 into A, where I know that the parallel path is equal to 2 because EMF induced in generator A, that is because of wave winding, because A is having wave winding, and in wave winding the parallel path will be equal to 2. So I will replace this parallel path into 2. And we know the number of poles in a question. So P in terms of 6 I can write. So this is EMF induced in A. So you can simplify this 6 ones are 6 tens are. So you can write it as phi Zn by 20. Okay. Whereas EMF induced in B, let me do it here. EMF induced in B can be given like this. Again phi Zn. These parameters we don't know the data, so let me keep it as it is. Whereas I know value of P is 6 divided by 60 into parallel path. Now parallel path for lap winding is equal to poles, so it will be 6. If I simplify this, we get it as phi Zn by 60. This is EMF induced in generator B. Now they are asking you to find a ratio of A and B. So take a ratio of these two. EMF induced in A is phi Zn by 20. So I will take it as phi Zn by 20 whole divided by EMF induced in B, that is phi Zn by 60. Phi Zn by 60. So here what happens, if I take it to the numerator side, this can be rewritten like this. Phi Zn by 20 into 60 by phi Zn. I am just simplifying it. So now this portion will get cancelled. And this is 20 and this is 23 is 60. So we got the ratio of EMF induced in A and B is 3 by 1 or 3:1. So the option B will be the answer for this question. Now let's move on for the second question. So the second question is something like this. Three identical resistors are connected in parallel and then in series. So there are three identical resistors. Identical is the same resistance. They are connected in parallel first and then in series. The resultant resistance of the first combination to the second will be dash. So they are asking you to find the ratio of the resultant resistance of each combination. First combination to second combination. So very first thing is, what is the first combination? You need to find that. So the first combination is parallel. They are initially connected in parallel. So find R equivalent in parallel. And then second combination is series. So find R equivalent in series. And they are asking you the ratio of it. Okay. First combination to the second combination. So R equivalent in parallel divided by R equivalent in series. That is what you need to identify. So R equivalent in parallel means, first let us understand, they are not given what is the value of resistance. So let us take three identical resistance and name them as resistance R. Say 1, 2, 3 resistance are connected in parallel. Okay. So let me name this as the same resistance R, because it is mentioned that they are identical, equal. So let me take this as R. Now find the equivalent resistance of the parallel circuit. So we can say that 1 by R equivalent is equal to 1 by R plus 1 by R plus 1 by R. This is how we can find the equivalent resistance for the parallel circuit. Now if you take an LCM of this, we get LCM as R, and here we can take it as 1 plus 1 plus 1, that is 3 by R. Let me change the marker. This is going to be 3 by R. Okay. So 1 by R equivalent is equal to 3 by R. But I want R equivalent only. So therefore R equivalent for parallel circuit will be equal to R by 3. Inverse it. So we get it like this. So we got R equivalent for parallel circuit. Same way, let us find the R equivalent for series. So for series, now change the connection. Same R will be connected in series like this. So we know that in series all these resistance will be added together. When I add R plus R, we get R equivalent in series will be equal to 3 times of R. Okay. Therefore, now we can find the ratio easily. R equivalent in parallel divided by R equivalent in series can be given like this. That is R by 3 whole divided by 3 times of R, which can be written as R by 3 into, if I take it to the numerator, this is going to be 3 by R, 3R by 1. So it will be 1 by 3R. So these ratios will get cancelled. It will be 1 by 9. The ratio of this is going to be 1 by 9 times of the actual quantity. So in option, here I have not mentioned the option, but in options it is like 1 by 9, 9 by 3, 3 by 1, 1 by 3. These are the options provided. This is the answer for that. Now let's take another example or another question which has been asked in the previous paper. So question number 3 is something like this. If 60 joule of energy are available for every 15 coulomb of charge, what is the voltage? So they have given energy, that is in terms of joules, and they have given the charge, that is in terms of coulombs. So they are asking you to find voltage. Generally, we all know that voltage in terms of V equal to I into R. Okay, that is current into resistance. But the basic definition, when you look into the basic definition of a voltage, it says that the work done to move the unit positive unit charge from one point to another point can be considered as a voltage. Okay, so according to that statement, the electromotive force or the voltage can be given as work done, that I indicate it as W, by to move the charges. Okay, so voltage can be given as W by Q, where W is a work done, okay, and Q is the charges. Alright, so work done means that is an energy, that is the energy invested to move the charges. This unit of energy is joules and unit of charge is coulomb. So the unit of voltage can be given as joules per coulomb also. Okay, So according to this question, they have mentioned that it is taking 60 joules to move the 15 coulomb of charges. So what is the voltage? This is the relation. So V equal to 60 by 15, that is 4 joules per coulomb is the voltage. Okay, so here the one basic thing we have understood that V can also be given, that is voltage can also be given in terms of joules per coulomb. It's not only this. This is also okay, but this is the basic definition of voltage. I hope you understood the concept and the questions what you have taken here. All these things are clear for you. If it is clear, it's better to share with others also so that they can also learn the things. So I request you to share, like, put a comment how actually you feel about this video. You put it in a comment and subscribe to my channel. Thank you.